Alright, today I'm going to do a short tutorial about the remainder theorem and the factor theorems topics, because actually one of my YouTube students actually asked me to discuss about this topic. So yeah, I'm going to do a quick tutorial. Okay, this topic is quite simple. Yeah, of course, first you have to understand what is the remainder theorem and what is the factor theorem. Alright, so I'm going to give you a simple example. What's the meaning for remainder? So for example, if let's say I have a 80, I have a 80 divided by 11. Uh, just a random example, right? So that means 80 we need to divide by 11. So yeah, when we divide this one, let's say 80, I will going to put a 7. 7 multiple 11, I will get 77. Then I will left 3. Alright, so in this case, what we know is our remainder actually is 3. So the 3 itself is a remainder. Okay, and actually all the answer, all the 80 and 11, they have their own names in this topic. So the 80 over here, they're going to call it dividend. Alright, and the 11, they're going to call it divisor. And the answer is 7, right? So the 7 itself, they're going to call it quotient. Right. Okay. Okay. This is just a name. Okay. It don't play a very important role here. So I'm going to give you another example, which is in this topic, which is we call it like dividend. Normally it won't give you 80. They will give you a polynomial. The polynomial normally is the function. So I'm going to like dividend, I'm going to use like fx. And then your quotient normally it will be a quadratic equation or cubic equation, depend on your questions. So your quotient, maybe I write a short form for quotient, which I call it qx. And your remainder, I'm going to call it r for remainder. Yeah, and your divisor sometimes will be the linear equation, sometimes will be a quadratic, sometimes will be the linear. Linear means something like x minus 2, x plus 8. All this we call it linear. Means the function, the polynomial divide by x minus 2, or the fx is divided by x plus 2, something like this. This one we call it linear. And if quadratic is something like divided by x squared minus x minus 2. This one is says your whole polynomial is divided by this one and ask you to find the remainder, something like this. So this is what happened in the divisor. Alright, so I'm going to give you an example in real life. So okay, so for example, so let's say I would say you have an equation fx is something like 2x power of 4 minus 5x cubed plus 7x plus 1. And then I would say this equation is divided by, is divided by maybe x minus 2. And then I ask you to find the remainder. Find the remainder. Okay, or we call it r. Okay, this is one of the simple partial questions. If the question come out something like this, you should be very happy. Alright, so most of the students, when they do this kind of questions, they will use long division, which is exactly like what we do here. So yeah, I will do the long division here. So this is my fx. I'm going to put at the locations of the dividend. So I'm going to write something like 2x power of 4 minus 5x power of 3 plus 7x plus 1. And you realize I leave a space here because when you do a long division, something is very important is you have to make sure uh, your x power actually will follow the sequence. So let's say this is x power of 4, x power of 3. You do not have x power of 2, so you have to add 0, x power of 2. This is what you always need to do for the long division. And then you have to make sure your x is from 1 to from biggest to the smaller lah. So x power of 4, x power of 3, x power of 2, x power of 1, and x power of 0. When there's no x here, means x power of 0. Alright, and divided by x minus 2. So I will divide by x minus 2. Right, then I will do a quick divide. So in order to eliminate the 2x power of 4, I will going to do 2x cubed. 2x cubed multiple x is 2x power of 4. 2x cubed minus multiple negative 2 is negative 4x cubed. And then here actually have an invisible minus. So this one gone, so you got 0. And this one you will still left negative, negative, positive. You will still net negative x cubed plus 0x squared. Then in order to get negative x cubed, I will do negative x squared. Because negative x squared multiple x, I got negative x cubed. Negative x squared multiple negative 2, I will get positive 2x squared. Remember, here have an invisible minus. So here actually you will get 0. And this one actually you will get negative 2x squared plus 7x. So in order to get negative 2x squared, I will minus 2x. Minus 2x multiple x is negative 2x squared. Negative 2x multiple negative 2 will be plus 4x. Then have an invisible minus here. So here we're left 3x plus 1. So in order to get 3x, I will write plus 3 here. So 3 multiple x is 3x. 3 multiple negative 2, you will get negative 6. So you have an invisible minus here, so you are left 7. Right, so in this case, we know that 7 is our remainder. Of course, this polynomial here, this is our fx, and this is our answer. I'm going to call it qx, and this is our divisor. So okay, this is some information. So we come back to this simple example. So over here, we know something is like, okay, in order to get 80, we know it's something like 11, which is divisor, multiple quotient, means multiple my answer, plus my remainder. So is divisor multiple the answer, your answer which is quotient, plus the remainder, which is 3. Okay, maybe I can write 3 here. Yeah, you can use calculator. This is 77 plus 3, you get 80. So same thing happens to the polynomial. So in order to get the fx, I will use the divisor, which is x minus 2, multiple the answer, which is qx, yeah, the whole cubic equation, plus my remainder. Alright, so okay, what is the purpose of the remainder theorem? The purpose of the remainder theorem is, let's say I give you the whole equation like this. Fx equals to the whole thing here is divided by x minus 2. Find the remainder. Let's say I do not want to use the long division. Do I have any faster way to actually get the r value? Because I want to get the r value here as fast as possible. So then the remainder theorem will come in. So what happened is, in order to straight away get the r value here, my objective here is to make the whole thing here become 0. So in order to get the whole thing here become 0, what I will do is I will make the divisor become the 0. So I will make the divisor become 0. So in this case, in order to make the divisor become the 0, you need to substitute x become 2, right? So if you substitute x become 2 into this equation, so let's say f2, you'll get 2 minus 2 is 0. 0 multiple the whole cubic equation here, mean the whole qx here, quotient here, you'll get 0. Then you'll leave r. Alright, so therefore, they come out a formula something like this. They will say when fx will equals to x minus a, this is qx, plus remainder. In order to get a remainder, we will substitute the a into x, because a minus a you get 0. So the whole thing here will become 0. Then you can straight away get r. Okay, so you must remember the idea of this one. In order to find the remainder theorem or factor theorem, because the factor theorem, the only difference between factor theorem and remainder theorem is the factor theorem have no remainder. That means you divide until here, your remainder will actually equal to 0. So the factor theorem's r is just 0. For remainder theorem, r will be some number, like in this case will be 7. So means the only difference between factor theorem and remainder theorem is the factor theorem, the r is 0. Okay, the remainder theorem, r is not the 0. Okay, so anyway, we come back to this case. So in order to solve this question without doing the long division, I want to find the r, is I want to make divisor, this is divisor, become 0. So in order to make the divisor become the 0, so you know you have to substitute 2 into x, correct or not? Because 2 minus 2 you get 0. So I can easily find the remainder by substitute 2 into my fx. So what happened is 2 multiple 2 power of 4 minus 5 2 power of 3 plus 7 2 plus 1. Alright, then definitely I will use the calculator for this one. This is 2 multiple 16 is 32. 5 multiple 8 will be negative 40 plus 14 plus 1. So this one will be negative 8, 6, then you get 7. You see, you can straight away get 7 without doing the long division. So this is the purpose of the remainder theorem. And of course, in the exam, they won't ask like this. In the exam, sometimes they will ask something like, okay, this fx is divided by x minus 2, and you will get the remainder equals to 5. Okay, maybe I give you some example on how the exam will ask. Okay, later we'll have a look at the example on the top. So I'm going to erase all this and give you some example. Okay, so yeah, the question always will say something like this. The fx, the fx is divided by, let's say, 2x minus 3. We'll leave remainder, or sometimes they will say we'll have the remainder 5, and then ask you to find a or find b, something like this. Of course, in this case, I didn't give you the equation of fx because I just want to explain the example. So what you will need to do is, for this kind of example, is since you divide by this one and leave a remainder 5, so what you will do is I will make this one become the 0. So you just do on a draft here. Let's say 2x minus 3 equals to 0. My x is equals to 3 over 2. Correct or not? Move the 3 and then move the 2. So what I know is my f 3 over 2, I will leave the remainder 5. Because when the divisor becomes a 0, you can straight away get your remainder. Alright, so or sometimes the question might say something like this. Okay, let's say the question might say something like this. X plus a is a factor of fx. Just a random example. Okay, this is just an example. So since I know x plus a is a factor of fx, that means I know I want to make the divisor become the 0. So that means I need to substitute negative 8 into here. So I will know f when I substitute negative a here, I will get my remainder. But then this one is a factor. Factor means my remainder over here, this one is supposed to be with r, but my remainder over here will be 0. Because I say, when we say factor mean we can fully divide the dividend and then we will get 0. Alright, so for example, let's say I have a 16 here. We know 2 actually is the factor of 16. Why? Because when I put an a here, I will get 16, my remainder is 0. So therefore, we know 2 is a factor of 16. Because the remainder, we will get 0. Okay? So this is some very important concept. Okay? And then actually, I will discuss one of the past year question in this video. Just make sure you can roughly understand about what's the remainder theorem and factor theorem. Okay? So, before I go into the question, so we come out with a conclusion here. So the conclusion here is something like this. If this is remainder theorem, you always need to write something like this: fa will equals to r for remainder theorem. Right. If this is factor theorem, you always will need to write something like this when fa will equals to 0. This is factor theorem. And how I get the values of a is I trying to make the divisor become 0. I trying to make the divisor 0. Okay, then you can get the a. Same thing for the remainder theorem. Alright, if you understand this one, we're going to go into the one of the past year question. Okay, it's over here. Okay, the past year question is something like this. The question will say the function fx is x cubed plus x squared plus ax plus b is divisible. Divisible here actually is the same meanings with the factor. Divisible mean it can fully divide, then the remainder will be 0. So it's the same meaning with factor, if you understand that. Alright, it's divisible by x minus 3 and leave the remainder of 20 when divided by x plus 1. So when the question says divisible by x minus 3, so what I will write over here is I will write I will make the divisor 0. That means I need to substitute 3 into my x. That's why I will write f3. I will get 0 because the question tell me it's divisible. This is one of the very important thing for remainder theorem. Make sure you write it. Then the question will say and leave the remainder. Leave a remainder of 20. That means I know 20, this one is r. When divided by x plus 1. So I want to make the divisor over here become 0. I will need to substitute the negative 1 into my x here. Then I will write something like this. F negative 1, I will get 20 because 20 is my remainder. Remember fa equals to r for remainder theorem? Yes. So this is what happened. Okay, then you realize that you have two equations here. Then you have two unknown a and b here. Then you can easily find the values a and b. So the question actually asks you to show that the b equals to 6 and find the values of a. So I will need to use these two information to form two equations and to find my b equals to 6 and find the values of a here. So when f3 equals to 0, so what I will do is I will substitute 3 into all the x here and make it become 0. So therefore, I will do like this: 3 power of 3 plus 3 power of 2 plus a3 plus b equals to 0. Alright, this one I'm going to write somewhere there because not enough space here. Okay, this is f negative 1 equals to 20. Yeah. So from here, I will form the first equation. Is 27 plus 9 plus 3a plus b equals to 0. So in order to find the b first, I will make the a as a subject. Alright, so I will say 3a, this is 36, equals to minus 36 minus b. So a basically is divide 3 is negative 12 minus b over 3. I divide 3, divide 3, divide 3. Okay, simple. I'm going to call this one first equation. Alright, then I'm going to do the same thing for my remainder theorem. So this one means I'm going to substitute negative 1 into all the x here, and then I will get 20. I'm not going to get 0 because I have a remainder in this case. So I will get negative 1 cubed plus negative 1 square plus a negative 1 plus b equals to 20. Then I will solve this one. This is minus 1 plus 1 minus a plus b equals to 20. So negative 1 plus 1 is 0. So I will get negative a plus b equals to 20. Then this one is my second equation. Then I do simultaneous. I'm going to say sub my first equation into my second equation. Then what I do next is I'm going to sub the a into here. So it will be negative. A will be negative 12 minus b over 3 plus b equals to 20. So a negative multiple in will make both become positive. So it will be 12 plus b over 3 plus, this is 1b, okay, equals to 20. So I move my 12 to the other side. This one is minus 12 will be 8. B over 3 plus 1b, basically I will get this one is over 1. I times 3 here will be 4b. Yeah, it will be 4b over 3. So if this one is 4b over 3 equals to 8, then in order to find a b, I will make the 4 over 3 become 3 over 4. Then I simplify 1 and 2 here. My b equals to 6. Then I will write shown. Because the question asked me to show that my b equals to 6. Yeah, so show that the b equals to 6. So I already show b equals to 6. Then I will substitute into a to find the values of a. Alright, so over here I'm going to say sub b equals to 6 into 1. So I sub into here. So a will equals to negative 12 minus b is 6 over 3. Then what I will get next is I simplify this one. I can get my a. This is negative 2, will be negative 14. Alright, then I already solved the first part. My a is negative 14 and my b is 6. Alright, then the question says using the values of a, which is negative 14, and taking b as a 6. So he asks you to take the b as a 6. Obviously your b is 6 also. So find the non-integer root of the equation fx equal to 0 in the form negative p plus minus square root q, where p and q are the integer. Alright, so from here, when you say the non-integer root in the question, something will come into your mind very quick is, you know you will need to use a formula. And the question will give you another hint is this one. You want to get the b plus minus square root q. So what formula you will need to use over here will be x equals to negative b plus minus square root b squared minus 4ac divided by 2a. Because if you use this formula, you will always get the non-integer root because there's a square root here. But not to say always. Sometimes you will get a whole number as well. But most of the time you will get most of the time when you see the words non-integer root and the question asks you to solve the equation in this form, p plus minus square root q, this one will be always the right formula to use. Right? So you must always get the hints from the question. Right? Then, but we have a problem here. This is a cubic equation. But this formula can only use for quadratic equation. Okay, quadratic equations mean the only x power 2. So it's ax squared plus bx plus c equals 0. So that means this formula cannot use for the cubic equation. So for this case, you will need to solve the cubic equation first, and then your quotient mean your answer. You will get a quadratic equation. Then you will use the quadratic equation, it will use this formula in the quadratic equation. Okay, maybe I'm going to show you how to do this one. So I'm going to erase this one because I will need a loss of space for this one. Okay, let me erase all this. And we know A is -14, B is 6. So, okay. So the first thing before I start to do is I will substitute the A and B into my fx first. This is x cubed plus x squared. My A is -14 and my B will be 6. Alright, I substitute everything into here first. Okay, now I will need to do a long division in order to get my quadratic equations over here to use this formula. Alright, so I will do a long division. My fx I will write inside plus x squared minus 14x plus 6, and then I will take the power of x 3, 2, 1, 0. Okay, it's fine because sometimes you will need to add a 0 by yourself. Alright, then I will need to think which divisor need to put here, because in this case I want to get the quadratic equations over here. I will always want to make sure my remainder is 0. So I will take the factor which is divisible one, or sometimes you will see factor which is divisible. So I will take this one, x minus 3, because if I divide by x minus 3 over here, my remainder will be 0. Then I can straight away use my answer to use this formula. Alright, I will not take x plus 1 because this one will leave me the remainder 20. So if you do the long division by yourself, all the time you just make sure you choose the factor, alright, or you see the word divisible. Then I will use the whole fx divided by x minus 3, and then I will do quickly here. In order to get x cubed, I will do x squared here, so I will get x cubed minus 3x squared, and then I have invisible minus here. This one gone. This one will get me 4x squared minus 14x. Then in order to get 4x squared, I will plus 4x. Then I will multiply. I get 4x squared minus 12x. So this one will give me negative here. It's still left negative 2x plus 6. So in order to get negative 2x, I will do negative 2. Negative 2 multiple x will be negative 2x plus 6. Then my remainder is 0. Right. So from here, the question says when fx, the question says fx will equals to 0. That means what? From here, at least I know something. My fx is actually equals to my divisor multiple my quotient, and the remainder is 0. Right, so I know my fx equals to x minus 3 multiple with x squared plus 4x minus 2 plus the remainder plus 0, but I will never write plus 0. So from here, the question tell me fx equals to 0. So what I will do is I will substitute this one, fx, into here and make it 0. X minus 3, this is x squared plus 4x minus 2 equals to 0. Then this one, we know that x minus 3 equals to 0, or x squared plus 4x minus 2 equals to 0. And x will equals to 3. This answer I will reject because this is not the question 1. The question 1 non-integer root. This is integer root. Okay, so non-integer root, that means is this one. So this one I'm going to use the formula just now to actually find out the non-integer root. Of course, in this one, at least you have to know your a is equals to 1, your b equals to 4, and your c equals to negative 2 because of ax squared plus bx plus c. Alright, then I will substitute into the formula here. So yeah, I'm going to erase this one and this one. Maybe I use green color. So my x over here will equals to my b is 4. Correct or not? My b is 4, c is negative 2, a is 1. So I'm going to substitute in here. So with negative 4 plus minus square root, b squared is 4 squared, which is 16, minus 4, my a is 1, my c is negative 2, divided by 2a, a is 1. Alright, then I'm going to solve this one. This is negative 4 plus minus square root 16 plus 8 is 24 divided by 2. Then this one I will need to solve this one because the question reminds us the answer must be p plus minus square root q. That means I cannot have the fraction over here, so I will continue solve this one. So this one will be negative 4 plus minus 24 itself will be square root 6 multiple 4 because I want to take a perfect square number come out here. This is square root 6 multiple square root 4. Square root 4 is 2. So I will get 2 square root 6 divided by 2. This is how we simplify here. Right, so then obviously both we have the 2 here. I'm going to factorize out the 2. I will get 2 negative 2 plus minus square root 6 over 2. Then I will simplify. Then I will get x equals to negative 2 plus minus square root 6. Done. This one is the non-integer root. Okay, root basically just means the answer of x. That means you have two answers, negative 2 plus square root 6 or negative 2 minus square root 6. You have two answers. Alright, yeah, this is how we solve this kind of question. Okay, so it's not too difficult. So first, of course, you have to understand the word something like divisible, or sometimes you will see factor. You will need to know, you have to apply the remainder theorem, something like fa equals 0. Then the question will give you another remainder and then divide by something. So you always need to understand you have to make the divisor become the 0. And then means fa will equals to r, and then r will be your remainder. And then most of the time you have the chance to do the simultaneous equation, means you will form 2 or 3 equations and then solve it to find your value a and b. And then the second part, sometimes the question will straight away ask you to solve. When the question asks you to solve without mention the non-integer root, so most of the time this equation you can straight away factorize like this. Then yeah, just use the simple factorize for your quadratic equation here. If you can factorize, the question will use the word solve. The question asks you to solve the quadratic equation. Then that means this one this one is given by the question. Is one of the factor, and then the quadratic equation you're going to just like simple factorize. Sometimes the questions will say, show that is only have one real root. So if you see something like this, the question says show that the fx has only have one real root. That means the whole fx over here only have one answer, which is x equals to 3. That means this quadratic equation cannot be solved. So how to show that the quadratic equation cannot be solved? This one we already learned in the quadratic chapter. That means you have to show that b squared minus 4ac, your final answer should be less than 0. Because if b squared minus 4ac less than 0, this one means no real root. When this quadratic equation have no real root, that means the only one real root in this fx is x equals to 3. Alright, so whenever you see something like show that is only have one real root, so what I will do is I will substitute my ABC into this formula, b squared minus 4ac, and then I will continue do until the end. My answer I should get a negative answer. So if I can get a negative answer, I will straight away write this symbol. It is less than 0. Then I will write shown. Because the question will ask you to show is only have one real root. Because the only root is the x minus 3, which is x equal to 3. Alright, yeah. It's a lot of information in this video, and I hope all this information will not confuse you too much. If you have any question, please post a comment on my Facebook or on my YouTube. If you have any more requests, just let me know. yeah, I will try to help you as much as I can. Anyways, if you like these videos, please share it out. And if you like this video, of course, you can give me a thumb up and subscribe this channel. Anyways, thanks for watching.